Today I'll solve one process calculation problem. Here is the problem statement. The ammonia oxidation process occurs over a catalyst as 4NH3 plus 5O2 is equal to 6H2 plus 4NO. Means ammonia react with oxygen and that will produce water and nitrogen oxide. So here air is supplied such that oxygen is 20% in excess of that required for complete conversion of NH3. Determine the mole fraction of oxygen in the inlet gas mixture where ammonia and air is there, and round up the answer to the 3 decimal place. So now what are the data given? So air, we know that air contains 79% nitrogen and 21% oxygen. So that is we have to assume. And here in the data oxygen is 20% in the excess of that required. Okay, so that these two datas are given. Now calculate required oxygen. So stoichiometry requirement of oxygen is given by this balance equation. So balance equation is given. So 4 ammonia plus 5 oxygen, that will produce 6 water and 4 NO. Now take that 1 mole of NH3. So for 1 mole of NH3, so required oxygen amount will be, so 4 here, if we from this that equation, 4 ammonia react with 5 oxygen, so that will produce 6 H2O and 4 NO. So here I am assume that 1 mole of ammonia is there in the inlet. So this is the basis. Okay, basis. So now how much oxygen is required to do the reaction? So here, so 4 mole of ammonia react with 5 mole of oxygen. So required oxygen will be 5 by 4. So that is 1.25 mole. Means 1 mole ammonia required 1.25 mole oxygen. So now in that inlet, the 20% excess oxygen actually supply. So required oxygen will be 1.25 into 1.2. Means as the 20% means that 1.25 into 120 means 1.2. So that is 1.5 mole. So that amount of oxygen is coming through the inlet. Now for this amount of oxygen is this amount of oxygen present as the inlet, for that how much air actually we have to send. So that we have to calculate here. So moles of air need to supply 1.5 mole of oxygen. So that will moles of air required oxygen by 0.21 because 21% oxygen in the air. So that's why required oxygen by 0.21. So that will be 7.129. So that much amount oxygen is air is required. So that much air is required. So now how much amount oxygen? So that is 7.14 into 0.21%. So that is 1.5. Already we got that. Okay. So how much amount nitrogen? So this is the total air. So 79% nitrogen. So that is for 7.1429 into 0.79. So that is 5.6429. That is the nitrogen. Now what will be the total mole? So total, this amount is air and 1 mole is ammonia. So that 1 mole ammonia, 1.5 mole oxygen and 5.6429 nitrogen. So that is 8.1429. Now we have to calculate mole fraction. So mole fraction we know that individual mole by mole fraction means individual mole by total mole. So now total mole. Okay, now here that individual mole means oxygen is 1.5 and total mole is 8.1429. So that is 0.184. Okay, so that is the mole fraction. So mole fraction of oxygen in the inlet gas mixture is approximately 0.184. That's it. Thank you.